let's take a moment and let's talk about finding the axis of symmetry from an equation, specifically looking for that axis of symmetry for a quadratic function or a quadratic equation based on the equation rather than looking at the graph. So let's start by reminding ourselves what exactly an axis of symmetry is. So hopefully you remember that an axis of symmetry are values that on an image or a graph that allow you to split that image or graph into two parts where those parts will line up on top of each other. For example, let's take the stop sign. We can draw a line right down the center, and then you could fold the right side onto the left, and it would match up perfectly if you look at those edges. That is an axis of symmetry, that dotted line through the center. In fact, there are actually more axis of symmetries in a single image in this case. So always keep in mind, it's possible to have more than one. So we have that original axis of symmetry right down the center, but we can also have an axis of symmetry in between these two sides. And in fact, in between these two and the last two. Every one of those has an axis of symmetry, and there are multiple in this image. You can even add another one in between each set of corners, and that would create yet more axis symmetries in this particular image. So you can have multiple axis symmetries for a single item. More common, especially when dealing with graphs, is going to be something a little more like this Batman logo, which has a single true axis of symmetry right down the center. That vertical line right down the center. Meaning you can fold the right half onto the left and every part of the image matches up perfectly. You'll notice it does not have a horizontal axis of symmetry because if you look at it, when you fold the bottom onto the top, it doesn't always match up in every place. The outer curve will match up, but the inside pieces won't, specifically the tail and head and then the wings. They won't line up and they're not exactly the same. So always think about that when you're looking at these graphs and images, what is and isn't symmetrical when you fold it over onto itself. Lucky for us, most of what we're doing is going to deal with simpler things, specifically graphs and parabolas. Now these parabolic graphs are super easy to work with because they only have one axis of symmetry. Every time that axis of symmetry is going to run right through the center of the graph, vertically, just like these do. So we can take this one on the right and our axis of symmetry runs right down through the center. Now, hopefully one of the things you're noticing is that these axis of symmetries cross through a very specific point on both these graphs. And it's a point we've talked about before. And that is these vertex or vertices for each individual graph. That's one of those key factors. An axis of symmetry will always pass through the vertex of a parabola. And in fact, when you get to find these mathematically from the equations, you'll recognize the equation from when we looked at finding the vertex. So let's look at this example. We have 3x squared minus 18x plus 1. And if you remember right, this is a standard form, which means we're looking for a, b, and c. We can identify those real fast by saying that a is 3, b is negative 18, and c is positive 1. Now, if we're going to find that axis of symmetry, which we know passes through the dead center of our parabola, it also passes through that vertex. So we need that x coordinate of the vertex. If you remember from when we talked about finding the vertex, the first part of our vertex is that x coordinate, and it's found by negative b divided by 2 times a. So, now let's fill in our formula. We have the negative of negative 18 divided by 2 times a, which is 3 in this case. And we can go ahead and keep simplifying it. Negative of negative 18 is positive 18, 2 times 3 is 6, and 18 divided by 6 is positive 3. So when we're looking at this, this is just our x-coordinate, but we need to turn it into this, our axis of symmetry. And in this case, our axis of symmetry is x equals 3. Now, you'll notice that I'm writing x equals 3, not just 3, and I'm not doing a coordinate point. We're not talking about points, we're talking about an entire line. And remember, the equation for a vertical line is x equals whatever that number is. that says that y could be any and every value, but x can only be that specific number, in this case 3. So if you draw a little graph, it gives us that vertical line going straight up and down. And that will always be the center of your parabola. Let's look at one real quick example talking about vertex form. So here's our vertex form problem. 4 times x plus 8 squared minus 9. So as we said, this is vertex form, so we're looking for h and k. And if you remember from when we're talking about vertex form, our h value is the number in the parentheses, in this case positive 8, and our k will be negative 9. Now if you remember finding our vertex from a vertex form problem, you remember that the vertex is the point negative of h, comma, k. Now, that's vertex form again, and the vertex of it. But we don't want the vertex, we want that axis of symmetry, which is only that x value. So, real simple, our axis of symmetry is just looking for that negative h value, or the opposite of the h value. So our axis of symmetry is real easy to find. We're looking for that negative value of h. So we can take our h value, find the negative of 8, go ahead and simplify it, and then we'll end up with negative 8. So in the end, our axis of symmetry, or our AOS, to abbreviate real quick, would be x equals negative 8. And there is your final answer. So you can see it's really easy and fast to find the axis of symmetry from the equation, especially when it's on vertex. Conversely, you can always say that if you're finding a vertex, you're going to find the axis of symmetry in the process of finding that vertex.